Okay, so I think we will begin now. Good evening, everyone. Welcome to our webinar today. I am Yashima and I'll be moderating today's session. Now, building performance simulation software can produce large quantities of data to aid decision making and build your intuition over a short period of time. But visualizing data is necessary step to aid analysis and to communicate how design decisions were made. In today's webinar, we will learn how to visualize and present quantitative information related to your design. Next slide, please. Before we begin today, I would like to acknowledge the support of the Department of Science and Technology, the Ministry of New and Renewable Energy, and the MacArthur Foundation. I would also like to acknowledge the support of the sponsors and affiliates of Solar Decathlon India. Next slide. We have with us today Dr. Saket Saraf. Saket is passionate about issues related to sustainable development and has over 20 years of experience in India and the US. He is the founder and principal at PS Collective, a platform for advocacy, research, policy analysis, and consultancy. His current work focuses on policy research and decision support systems in areas of energy policy, efficiency, and sustainable development. We welcome you today, Saket.
Thank you, Ashim.
And to all our participants today, please feel free to send in your questions anytime during the webinar, and we will take it towards the end of the webinar. And with that, it's over to you, Saket.
Thanks, Yashima. It's a pleasure to be here to be with the participants of Solar Decathlon India. And I wish all the teams best in their final deliverable. And I have been looking at the submissions from a 30,000 feet view, and it seems pretty exciting. And happy that in the first edition, the quality is so good. So today we'll be talking about presenting quantitative information. Now, I've seen many of the submissions and the quality is already good, right? So I'm not going to kind of tell you how to make graphs, right? I think most of you already know this. You're doing a great job of it. What I'm going to do today is to say, give you a structure of how to look at data, right? And then given the nature of the data and the kind of questions you're asking, maybe select a type of a graph or a type of a visualization, right? And then maybe how to build on it to make it more informative, either to communicate or to explore or to learn or to decide, things like that. So that's the structure. I'll be going at a very, very fast speed, right? Because I just want to give you a breadth of what is possible and what the basic off-the-shelf softwares can do, right? And by no means this is exhaustive, by no means this is all-encompassing, and there's a lot of scope to improvise and innovate here. Okay? So let's start. And as Yashima said, we'll take the questions towards the end. Right? But if there's a pressing question that is kind of affecting your understanding of what's happening, then feel free to send it in the chat window. So I would start with this poem by T.S. Eliot, 1934. He says, "Where is the life we have lost in living? Where's the wisdom we have lost in knowledge? And where's the knowledge we have lost in information?" Right? And that is something that happens to all of us when we have this data deluge. We have lots of data and we try to find information in that data, right? And then we have information overload. And then we say, okay, with this information overload, are we losing on the knowledge, right? And if there's too much of knowledge, are we losing on the wisdom, right? And so on. So this is extremely important because when you do simulation and you do multiple options, there's a data deluge. And the aim here is, the aim to deal with quantitative data is to kind of move up this pyramid from data to information to knowledge to wisdom, right? And how effectively, how quickly we can move up this pyramid would affect what we do with all the data that comes out of simulation, all the decisions we make, right? So simulation is not another checkbox in the submission process, but simulation is kind of a decision aid tool, the way I look at it, right? And it would aid you in your decision making. The faster you know how to turn data into information, information into knowledge, and then you use that knowledge to improve your proposal. Another way to look at it is you have data on the left. You have data, and then you convert it into information. You say all this data points, you color code, you say, okay, this data point means that, and the other data point means something else. Then you convert that into knowledge, you start connecting the dots. And the wisdom is then, after you've connected all the dots, what is the path, what is the way ahead, what are the decisions you take, right? So that is a journey we would want to make. Now, of course, we can't do all of that in this webinar today, but that is the overall intention, right? So the way you visualize the data, the information, and move to knowledge and to wisdom is by answering some very fundamental questions. Why do you want to present? What you want to present? How you want to present? And who do you want to present to? Right? An answer to all these questions would affect the outcome or the choice of the graphics and the nature of the graphics that you'll be using to present the quantitative information. And we'll have a short poll. Yashima, if you can help me with this.
Yes, so I'll be launching a poll and request everyone to participate. So I've launched the poll, and the question is, why do you want to present quantitative information? And this is a multiple choice question, so you can answer, you can select more than one option. And we have 10 options, so a huge variety. The options are 1, explore, discover, detect, confirm, understand, analyze, compare, summarize, decide, and communicate. And we have answers coming in, and I'll wait for 30 seconds since it's a long question. And then we'll share the results, Saket.
Sure, thanks.
Yeah. So once again, I'll request everyone to participate. The question is, why do you want to present quantitative information? The question is on your screen, and we request you to, so it's a multiple choice question. You can select more than one answer.
And it's not a trick question, so don't think that I'm going to trick you to do something.
Yeah, absolutely.
Straightforward question.
Yes. So another 10 seconds and I'll end the poll. All right. And here are the results, Saket. So
wow.
The least vote for detect, and we have similar percentage for analyze, summarize, and communicate.
Okay. Thanks, yeah. Yashima, and thanks everybody from participating. So I can see that can we have the results on the screen? It's vanished.
Yeah, sure. I'll reshare them.
Yeah,
yes.
Thanks. So I can see that, okay, analyze, compare, summarize, decide, and communicate. Everybody understands this. But all of this is, in my opinion, the second half of presenting or visualizing data, right? The first half, which is more exploratory, is to explore what is happening, and then in the process of exploring, you either discover something, right, or you detect things, and there's a difference between detecting and discovering. And then confirmation is something that not many people do. But confirmation means that if you're exploring and you discovered something, is that by fluke, is that accidental, or it's actually there, right? That is where confirmation comes from. And then rest of it were pretty simple, and I think most of you selected that. Right? So what I can see is there's a lot more emphasis in terms of the votes on the analysis and the communication part, but the discovery and the exploration part is equally important, right? And it is through the discovery and the exploration that you get insights that help you to maybe compare or summarize or decide or communicate, right? So it's very important to look at visualization also in this exploratory mode and in terms of discovery mode, because through this you would maybe find innovative ways to address some of the challenges you're trying to face, right? Okay, thanks, Yashima. So with that, let's move on. So this was the goals, and depending on the goal that you have in mind, right, you would then present your data in a particular manner. So if your goal is to explore, you would present the data in a particular manner, which is maybe a lot of options, a lot of alternatives, quick, dirty ways, which allows you to do maybe 10, 20, 30 visualization, and then through that you explore what is happening, right? And when you're towards the end, when things are much more firmed up, then you would not make so many alternatives, right? But you would know which of the visualization really helps you to do that specific task properly. The choice of visualization also depends on the type of data you have, right? So you would be familiar with temporal data, data that varies with time. So you would have data for every hour, or every 15 minutes, or data for day or months, and so on. Data, if it is partial, so say daylight availability in different parts of the same room, right? So that's a spatial data. So again, depending on the nature of the data, you would have a different visualization technique. Similarly for flow, right? So how does energy flow happens through the building? It comes from somewhere, it gets absorbed, it gets cooled, it gets thrown out of the building, or how does water flow through the building, and so on. And so if you're looking at flow data, then you will have a different set of visualization. And then hybrid is combination of one or more of these. So you can have a spatio-temporal visualization. You can have flow through space or flow through time, uh, uh, and so on, right? So depending on, again, the kind of data and the question or the goal of visualization, you would choose one or the other style of uh, making graphs. Now, this presentation is not to help you to make beautiful graphs, to make good renderings. For that, there are some classics which are listed on the screen on the right, maybe. Um, but we will be looking more at, how do you structure and organize your thought process given the kind of data and the kind of questions you have in mind to select the right graphics, right? And end of the day, the choice also depends on the audience. So are you doing it for yourself? So if you're doing the visualization for exploration to as a precursor to a decision making step, then you are the audience, right? And you visualize and you analyze the data, and then you put it somewhere so that when you come back to it after a month, 2 months, you know how the decision was taken, and how confident are you about the decision. Then also to share the analysis with your team members, to and share your analysis with your project partners, with the jury, and so on. And each of the audience would have a different level of data literacy, right? So again, you'll have to kind of tailor the complexity and the ease of storytelling depending on who your audience is. So this is the larger umbrella here. So let's then jump to visualizing different kinds of data, right? And I'll start with visualizing temporal data now. Now, temporal data is data which is collected, which is available with, say, some fixed frequency. And so you measure data, or the simulation would tell you data every 15 minutes or an hour or so on and so forth. And you would have data which is periodic for the temperature or carbon dioxide level or any other thing like thermal comfort for that matter, right? And then the lesser known type of temporal data is events, that things happen, right? So suppose you are having a mixed mode building and people are actually opening and closing windows, right? So that's an event, and it may not happen at fixed interval. So if you're looking at, say, a wind data, you would have wind data for every hour or every 15 minutes, and that's fixed interval. But if you're looking at operations, or if you're looking at when does the set point kick in, when does the system start or switch off, right? Then these are events, and they may happen more randomly and not at fixed interval. And then it takes a whole different set of visualization techniques to look at such events. Even the notion of time itself varies depending on the kind of exploration and the kind of decision you're going to make. Time can be looked at ordinal, sequential, cyclic, discrete, interval, hierarchical, implicit, and so on and so forth. And depending on the notion of the time, you would have a different visualization. And sometimes we don't think about time so formally when we're visualizing data, but we'll see that in some examples how if you just change the lens by which you look at the time, you will be able to create to arrive at very different and very exciting insights of how things are, right? So I will kind of not explain these, but in the examples, maybe I'll tell you that in this version, the time is linear or discrete or hierarchical or implicit and so on. So let me start with very simple, the simplest visualization. You have the temperature hourly data for temperature for the whole year 8760. And here I'm just looking at the data for a day, say 24 hour, right? And looking at what is happening between morning and evening. So this is the simplest graph that you can do, right? And in addition to temperature, if I'm also interested in say humidity, then I'll make the similar graph, right? Now either I can have the two graphs side by side, or I can superimpose, and then I can see that, okay, when temperature is going up, the humidity is going down and vice versa. And this now tells me the relationship between two variables uh, with the time which is moving linearly, right? Now, what I can do is instead of looking at the time linearly moving on the x-axis, I can say what if time is implicit. So I'm just looking at the relationship between humidity and temperature here, where there's no time on any axis, right? Now here, what I can see is that as the temperature is increasing, the RH is going down, right? And or if the RH is going up, right, then temperature is decreasing. Right? So this is something that we don't do very often, but it sometimes adds a lot of insight to say, okay, it's a temporal phenomena, but what if the time is implicit, right? And if I just now connect the dots and put the time interval, then I can see that from midnight towards the morning, the temperature is going down, right? And then say around 9 o'clock, the temperature starts going up and the RH goes down. And then in the evening again, then the temperature goes back, right? So then you get a very different way of looking at how two variables are moving through in time. Okay? And you can do the same thing. This is for inside a room, and this is for outside, right? And if you just juxtapose them together, you get a very different insight saying, okay, inside the room, the temperature band is not very large. The difference between maximum minimum is less than what is happening outside, right? And same thing with RH. So the inside temperature is not as varying as the outside, but also you can see that the area in the inside room is larger than the area outside. So it can give you insight on the thermal capacity of the room, that how much time does it take for the system to come back to the initial point, and things like that. So it's a very nice way, the minute you make the time implicit, to say what is the thermal capacity of the space. And just for fun, you extend it for the whole year, and then you can see in different months, what is the relationship between RH and the dry bulb temperature. So each color is a month, and you can see that in the blue month, the temperature variation is huge, the RH variation is also huge. But say in the cyan month, the temperature variation is not huge, but the RH variation is huge, right? So just by throwing out the time from the graph, you can get some other interesting stories to tell, right? And now I'm not covering things that all of you know, right? But I'm just saying, okay, what are the other ways to look at the same information? Moving from hourly data, you can move to looking at things at a weekly level, right? And then this is an example of how to look at occupancy in different spaces for the whole week, right? And then you can look at occupancy in different spaces, and then you can have an overlay of the mean occupancy, right? And therefore you know that what is happening in the weekends compared to the weekday, and when there's a lunch break and there's a peak after the lunch break, and so on. But behind this is much more detailed data for different spaces. So even if you know that the mean occupancy is of a particular shape, the occupancy for different rooms are different from the mean, right? And this again gives you different insight, that just having the mean or a median occupancy may be misleading if you're doing occupancy related measures, which may be a control measure, which may be a cooling measure, and so on. Another way to look at the same data is to say, okay, what if we have the same 24-hour period, but now we kind of summarize, right? So what you saw here is the raw data in gray and a summary data in black, right? And we take it to the next level, and we say, we take the raw data and put it in a box plot form, which is in the back. And now you have a much more stronger black line, which says occupancy in a 24-hour period, which is an average, say, for the whole month, right? But then you have a layer behind which has individual occupancies at that particular hour, and then it gives you a sense of what is the variation in occupancy at a particular time. Even though the mean gives you one number, you would know that that number is just an average, and the real occupancy is varying a lot, right? And then take this idea ahead to looking at the whole data for the year, and then you say, okay, what is the general trend for the year, right? But also what is the variation in each month, right? And this you can do for temperature, you can do for many other things. Uh, Another way is to have all these bar charts, which kind of tells you what is happening every month, right? But um, a box plot kind of gives you a little bit more insight into the variation within the month, and the bar chart just gives you a aggregate number for that month, right? And again, depending on the goal and your audience, you may choose one visualization technique over the other, right? And then you extend it further and you say, okay, not only what is happening in that month, but what are the different components in that month, maybe in terms of input or output, right? And then you color code them accordingly with a nice legend, and extend this further to say, okay, this is what is happening in the month, but what is happening on a particular typical day, say a cooling design day and a heating design day. And then you compare the typical month with what is happening in different months. And then this process of exploration adds a lot of insight into which months are cooling intensive and which months are more heating intensive, right? Um, Extend it more to say, okay, rather than aggregate data, let's look at hourly data for the whole year 8760, and this is called a heat map. And then you can do the heat map for different variables and juxtapose them on top of each other, change the color, and then it starts generating a different kind of insight, right? So just zooming in to say what are the comfort hours, uh, and then each pixel is actually an hour. And I'm sure all of you are aware of this way of looking at the data. But then you add a layer on top of it to say, okay, that was the raw data, and now there are bands in which you would say that when the air conditioning is on, when people are comfortable, and so on, right? Or what is the lighting level outside. So all that we're doing is taking the raw data, converting it into information, and then summarizing it in a way that leads to some knowledge about the issues that can help you to design better. Again, what I'm doing here is constantly going between raw data at, say, hourly level to weekly level to monthly level to annual, and then maybe come back to daily level and say, uh, put the whole thing in a calendar format. And then this becomes very easy for a lot of people to understand that what is happening in January to December, what is happening on weekdays versus weekends, how is January different from, say, September, how is Monday different from a Friday, right? So you then start looking at these patterns, stretching the same idea ahead. Instead of one variable, now you have this 12-month period, but you can do the same thing for 4 different variables, and then you just stare at it for some time to say, are there patterns evolving out of it, right? And it is these patterns that pop out. Then you can do a little bit more analysis to say whether those patterns are actually there or they're just figment of your imagination. And then you can do some more confirmatory analysis on top of that, right? But some of these may not be very palatable to non-technical people, right? So these are more exploratory in the nature in that sense. So uh, let's quickly say, okay, once you have this raw data, can we do more layering and synthesis that helps you to generate insight? So this is again, say, 8760 hours, and then you convert that into box plot, right? So it's very difficult to say what is happening in this top graph here, but the minute you start synthesizing and summarizing, then you can know that what is the variation, average variation across the month, and what is the variation within each month, right? So this is one layer, one step ahead from just looking at the raw data to the summarized data, because it's very difficult to take any decision just by looking at the raw data. You just information data overload there, right? And now you would, on this, you can be sure that, okay, the variation between the months is not huge. This place is whatever variable you're plotting pretty much standard throughout the year, and the minimum and maximum is also not very huge, except something is happening in December, and that may be due to a holiday or something else. Right? So you start speculating that why is one month very different from others, and then you go back to other variables and say, okay, this is the reason why December is looking different from, say, January or February. Okay. So this is one way to kind of move one step up from just plotting the raw data. Other way is to say, okay, you have the raw data, then you add, you start layering. You have the raw data in here, and then you add a layer of, say, comfort band, and then you highlight certain dots, right? So this is what I call layering, that instead of just presenting the raw data or inundating your audience with raw data, you say, okay, what is it that I need to look at in this graph, right? And so you highlight something, and then you add colors to say, okay, these are the dots I want you to focus on, and not stop that, annotate the whole thing with more information on the bottom to say, okay, this is what I learned from this visualization, right? These are the takeaways. Because when you're putting this in a report or making a presentation, people may not have enough time to look at all this 8760 data points and then come to the same conclusion in a very short span of time. So you're aiding people to not only look at the outcome, but telling them that what process you use to reach this outcome. That, okay, when is what kind of cooling system required, when are people going to be comfortable, and so on. Other way is to look at time as more hierarchical. So you not only look at, say, the hourly data, but then you summarize it in some way that you get, okay, what is a typical day in January? What does a 24-hour in January look like? What does a 24-hour in July look like, right? And then you say, okay, a typical day in July is very different from typical day in January. And that means a strategy for July can be very different from the strategy for January. Right? And it's very difficult to do this just by looking at 8760 hours. So here you can look at time as in a hierarchy, that there's an annual flow of time and there's an hourly flow of time. And then the visualization is kind of integrated, that it constantly goes between a 24-hour cycle and a 12-month cycle, right? But there's no information loss, and it helps you to synthesize time across different scales. Another way to look at hierarchical time is, suppose this is 8760, then you decompose it in a manner that gives you the annual trend or trend across the months, right? And then from that you distill what are the cycles. So these cycles may be, so the trend can be of different months, and then the cycles can be weekly cycles, right? And the sub cycle can be, in each week there'll be a cycle of different days, and then there'll be some random component because the weather itself has a randomness, right? So you look at the whole annual thing and then decompose into smaller parts, and you're constantly then saying, okay, this is what is happening at the weekly level, this is what is happening at the monthly level, and this is what is happening at the hourly level, right? And this then helps you to understand how your building is reacting to different weather elements and occupants. Another way is to say, just take two variables and then say, how can I cluster it so that for different clusters I can have different strategies. So assume that this is about temperature and RH. So you may have one strategy for the parts of the year which is low temperature and low RH, and then you say, okay, this is a control strategy when the temperature and RH is both low, and then another strategy when the temperature is high but RH is low, and a third strategy for places when temperature is high and RH is also high, right? So then again you look at variables, say in this case, which affects comfort, and then say what are the different clusters, natural clusters that emerge from this, right? And then for each cluster, you would say, okay, this is my strategy. Okay. I'm seeing there's lots of message in the chat. Okay. So, and then you take the idea of cluster to the next level to say, okay, how you can do this cluster more intelligently to get a higher level of insight. And some of these things are not required regularly, but it's easy to push the performance, say, from 50% to 90%, right? But if you're trying to push the performance from 90% to 95%, then you have already exhausted a lot of the analysis and the visualization techniques. And then you really need to go deeper to find the weaker signals that allow you to improve the performance of anything, right? And that is where some of these advanced techniques may kick in. Okay. Then there is another set of techniques that you can use to visualize large number of variables or large number of data points. Right? So if you have a building with say 20 spaces and you want to look at what all is happening in all the 20 spaces, right? And if you want to say what all is happening at 8760 hours in all the 20 spaces at the same time, right? Then the complexity of the data increases, and then you need to kind of go beyond the traditional styles of looking at the data. Okay? And the more things you can look at together at a go, the more I think insights are there to be discovered. Okay? And therefore those discoveries then can lead to better design decisions. So this style is called small multiples. So if you have lots of variables, you can make nice looking area charts, but just compose them together. So it's not always that it's one chart, but you can make a panel of charts, and then you stare at the chart to say, okay, are there things which pop out? Are there things which are connected? Are there correlations between them? Right. So you can very easily start looking at multiple charts and either focus only on one chart or look at all the charts together, right? And the more you stare, more the chances of discovery and detection. And once you have discovered or detected some pattern, then you can go to the next level to do some analysis to say, okay, are those correlations, are those patterns actually there or not? Other way is called Sparklines, okay? And where you can actually plot, say, hundreds or 500 or 1,000 of time series on a single graph, right? And again, this is very useful if you're looking at very finely looking at things happening in different spaces in the building or across different variables to say, is there an anomaly? Is my software behaving right? Are there some spikes somewhere? Is there a constant simultaneous cooling, heating? Is there a window left open, right? So any uh, abnormal behavior in any of the variables, you can just plot everything together and then see what is uh, different, right? Then there's something called overprinting. So if you're plotting everything, say for 365 days, you can do that. And then you can use some level of opacity for each line and then start finding patterns in there, right? And this is very useful to say how do, say, energy consumption in a 24-hour cycle period vary in summer, winters. But here the summer winter definition can itself arrive from the individual load curves. So this is something a little bit beyond what most of the participants do. But I think if you really want to push the performance of your building, in the last quartile, then you need to go beyond the basics. Now let's quickly look at some ways to look at spatial data. The spatial data applications are in the daylight, temperature, comfort, carbon dioxide level, view sheds, and many other things where you need to say what is happening where, right? And to complicate it, you can say what is happening where and when, right? So that will be space-time visualization. Okay? And the spatial data, some of the examples I'm sharing here are, okay, what if you want to look at one space and one variable, or one space and the whole floor or many floors, or look at many variables spatial, right? So these are some of the examples, but definitely they're not all encompassing. So just, and again, this is very simple. I think all of you are already doing this, looking at say daylight in one room using some color map, right? And you can extend that to walls in the same room, right? You can have different metrics, right? And you can even do the same thing in a manner that is more palatable to, say, a non-technical audience by using some false coloring. This example is, I think, of artificial lighting, right? But this is how you would look at one variable in one space. And then if you want to look at this one variable in the one space, but over time, then you can have a panel of uh, such maps, right? So you can say what is happening in daylight, say in December in the morning, or some other month and different times of the day. Right? So it gives you the sense of the light levels in that room across the year. You can also juxtapose a simple visualization with false rendering and a 3D view to improve the what I'd say for your audience, for them to make better sense of what is happening in that space. So this is an example, and Jane here is Yashima Jane, who is with us. So this is from her thesis. Um, if you're looking at spatial data, say for one floor, and it's another example, we're looking at spatial data for the whole floor of the building. Then here is an example where you have multiple variables for the same floor, and you just juxtapose them on top of each other with some summary statistics, right? And this is fairly complex maybe for a layperson, but for the design team, it's a very powerful tool to say, okay, how are daylight and comfort and ventilation, everything coming together for that floor, right? And so it has the visualization, it has some metrics, and then the team can sit around this and say, okay, we need to have some daylight uh, related strategies here. We need to improve the ventilation or do this to improve thermal comfort. And so the same visualization, which is more complex, it's coming together of different things together, becomes a very good engagement tool to arrive at a design decision. If you want to extend this to multiple floors, sometimes it becomes difficult if the floors are overlapping, so you can't see. The higher floors would hide things in the lower floor, and then you change the angle, and then you can look at daylight, say at multiple floors of the same building and alternative scenarios. So on the x-axis, you have 3 different scenarios, y-axis is different floors, and then you get some summary statistics on what is happening at different levels. Right? Another way is to look at multiple floors and multiple options. So this is one option and second option, and you can then compare floor wise what is happening in these two options of different WWR, right? Again, another example of multiple variables, right? So same option, multiple variables and multiple floors. So it's different way of just slicing and dicing the whole thing. But the whole idea here is the more alternative ways you create to look at your building, there's more chances of saying, okay, this is happening here, which is acceptable or which has a scope to improve. And then you have a very targeted design intervention, right? And again, the aim here is to identify places where the energy can be uh, saved or comfort can be improved or daylight may be improved, right? So the more you kind of play with their data, the more chances of discovering such insights are there. You can extend this to looking at buildings in sections, a very conceptual sketch to a little bit more informed sketch to more computationally driven sketch, right? Now, all these are important. When you start, you can start with a very conceptual thing. And towards the end, when you're more sure about what is happening, you can have more credible, more rigorous way to say how is the temperature gradient in that space, right? The same with building components, window frames, wall assemblies, how the heat transfer is happening. So all of this is about the spatial data. Next, I would jump into how to look at flows, right? And I think this is extremely important. From all the submissions I've seen, I think students, participants have done a great job in temporal data and in spatial data. But I think there's a lot of scope to improve information on the flows. So I would be spending some time on the flow data, right? And again, flows can be flows about wind, it can be flow about water, the flows can be about energy and so on, right? Flow of people in the building for that matter. So you can, again, flow data can be visualized very conceptually, uh, and then say, let's add something to this conceptual plot to say, okay, it's not only how wind is flowing, but is it a hot wind or is it a cold wind? If it's cold wind, where does it pick the heat from? And the wind that goes out, what is its temperature? Then you kind of move from there to adding more value to it, uh, maybe through more heuristics or through CFD to exactly look at the wind patterns inside the building. And if you want to go to the next level, you would say, okay, what is the temperature of the wind? What is the direction of the wind? What is the speed of the wind? The vertical speed, the horizontal speed, and you can just build in all those things depending on how much you want to push the idea. Right? Um, Water flow is critical, and visualizing the water flow is extremely important um, to not only design better water systems in the building, but also to communicate and to convince your audience that what is happening in the building and is it efficient or not. So this is one example where the flow is very technically shown. It's technically quite strong, but it would take a lot of time to understand what is happening in the system, right? Uh, and this is one level. Build on top of that, where you take the same technical information, but now you put it in the context of the building, to and maybe as a section in your building to say where water is coming from and where it is going, right? So it becomes much more intuitive in that sense, and then you color code different lines to say, what part of the water system they belong to, right? Or you can subdue the building and highlight the water flows, right? So this is a slight improvement on that, right? And then you start throwing in some numbers here, and maybe then say, okay, we get the flows, but let's look at the numbers, the volume of water, and then you can then add all these numbers, right? uh, but still every step there's an improvement, but it would take a lot of kind of eyeballing to say, okay, what is the water coming out of faucet versus a washing machine versus for drinking, right? And so you take it to the next level where you change the thickness of the arrows depending on uh, the volume, right? So how much of water is coming from, say, a faucet versus a washing machine would be shown through the thickness of these arrows, or maybe more abstractly. And then you would know, okay, if you just look at this diagram on the right, you would know how much of rainwater is coming, how much of fresh water is coming from pipe, and what is going to the soil, right? So at every step, you can know the thickness of this thing, and you say what percent is recycled, and so on. And take it to the next level of abstraction. And with a diagram like this, you would now it becomes very easy to say, to understand that what percent of the water is recycled, where it is going, where it is coming from, right? So looking at the flow and visualizing the flow not only helps you to understand where things are getting wasted, where the bottlenecks, or where the scope for improvement, right? But it also helps to communicate your whole methodology. And it's easy for your audience to say, okay, does this look feasible or not? Have you missed something? And so forth. Right? The same logic can be extended to flow of, say, heat into the building, uh, flow of heat and energy and electricity. So the logic is same, that the size of the arrows show the volume, and then it's okay, it's going from this box to this box, right? And it's splitting or it's coming together, and you can then do the flow across time. So this is the flow, say, in January, and this is the flow in July, and then you can say, okay, how much of energy is going into the cooling and how much is going into say domestic hot water and so on, right? And then you can also do it from the source of the energy, how much is from renewable and to what purpose it is being used for, right? So this was all about flows, say, and you can extend this to many more things, like financial flows, uh, how much of money is being spent, say, for energy in different time of the year. Another set of visualization that I want to quickly touch base on is how do you compare scenarios, right? So in early design stage, you would have all these different alternatives, right? And then you are just interested in a ballpark, uh, say, EPI values for these alternative scenarios, right? And then you presented something like this in the final stage to say, okay, we explored 10 different alternatives in bulk and height and massing, and this is what we found, and this is why we picked one alternative over the other, right? So very simple. The message here is these things, though the back-end analysis may be very complex, when you're presenting, they can be presented in an extremely simple, elegant manner. Where good thing is you have on the left here the physical building, which is very easy to understand, right? And then a corresponding technical graph, and then on the right the takeaway message. Okay, so for a very lay person in your audience, that person can look at the building mass, which is quite clear, and then say, okay, what is the message? What is your takeaway, right? And for those who are more technically inclined, they can say, okay, why is this the final takeaway? Then they look at the graph in the center and say, this is what is happening and which is leading to this takeaway, right? And then you have the next question, why is this happening? Because then you can go back to the massing and say, well, you look at this and here there's more window and there's less window and blah blah blah, and therefore from A you can go to B and B to C, right? So this is how you can layer different information so that the same graphic can appeal to audience having a varying degree of technical expertise. Just some more examples again, but what is common amongst all these things is you have a very simple graphic on the left which tells you about the building, uh, the architecture, the design, then simple metrics, and then maybe more detailed metrics, right? So it's always layered, um, so that you can quickly come to a decision, but it can be backed in the same graph to say why this decision is there. Another thing that I've observed is buildups to say, okay, this is the base case, and then you do something, and then the energy is this, and then you keep on adding things, and the energy kind of, this is the final energy consumption, and then you say, okay, this is the base case, and this is the proposed case, and how much of energy is saved, right? Uh, then you can maybe add more value to this by saying, okay, each of these bars you would divide into different components, and then say this is the base, and then gradually you keep on reducing, right? So this is a very standard way of looking at things, to say, okay, this is the initial case and this is the final case, and what is the saving, and you annotate and you add more value, add more details. And but in my opinion, it's very difficult to see how has individual components changed from one option to the option on top of it, right? So you can flip this style of visualization into something like this. You say, okay, this is the base case. If I do this, then what are the components that decrease, right? And then I add on something, and then I can say what is the decrease. And every time you add an intervention, you are kind of shaving up some energy consumption, and then you come with the final case, right? And then you compare the base case with the final case. So this is more intuitive, that in each addition, each build up, each energy conservation measure that you're adding, you can see what is the impact of that individually, and also in reference to the larger whole, which is somehow not very apparent here. And then it's very easy to say, okay, which intervention is kind of the maximum bang for the buck, and in that, what is the component that is maximum saving. Right? Another way to look at the same thing is that this is how your initial consumption is. Then you have all these ECMs, and you can say where, or this is energy balance. So you can say, okay, this is total consumption. Some part of it is coming from PV. A large part is going into streets. Then this much is only being used in the building. And then you add some new PV to the site. And then this is what is the gap, and if you want to make it net zero, then this is what the renewable component has to be, additional renewable component that has to be added, right? But it's again saying this is your starting point, and you start sharing things from different interventions, and then you see what is left with it, right? So this, I think, is an improvement over just blank bar charts. Another thing that I've seen in a lot of submissions is to visualize components of something. So you can make a pie, and then if the pie becomes too complicated, take one slice and detail that out separately, right? The literature is very divided on whether the pie is an effective way to display shares of something, and then there are numerous alternatives to using pie directly, right? And you can then look at these at leisure, but these are different ways to to show the share of different components of something. So another example where you have many components and you want to look at the share of components under two different scenarios. Now it's very difficult to kind of compare the individual components like this, right? So one way to improve upon something like this is, one, always do it horizontally, because eyes can compare things. It is easy for human eyes to compare things vertically, and then adding these lines can say which part is expanding and which part is contracting, right? And then again, there's no right way, there's no one way, there are multiple ways to slice and dice the whole problem. So you can compare it like this or compare it like this, uh, and then see which tells which method allows you to tell the most powerful story. Okay. One interesting way to compare things, and especially if you have time, right? This is not necessarily required. This can be applied to anything, but especially when you have time periods, is to say, and especially if the time period is also varying, right? This can be applied to fixed time intervals, but say January is kind of 1 month, and then February, uh, March, April is 1 month, and May, June, July, August is another month. Then you have a short monsoon, and then something, right? And in different time periods, what is happening to different components, right? And then you can say, okay, this, whatever this blue component is, how it is varying across the year, and how is the year divided into unequal components, right? And then this way is, it breaks the rigidness of of the bar chart that you saw in the previous slides, right? And it adds much more insight to what is happening around the ear. So closing remarks, when you're choosing your visualization style, remember these 4 fundamental questions: why you're doing what you're doing, what type of data you're visualizing, how do you want to present, and who's your audience, right? And then, of course, the final outcome should meet some basic principles of good visualization, and the three agreed upon principles are: it has to be trustworthy, right? That if I should have a confidence that whatever is being shown is correct. There's no technical gaps in this, or there's no technical lacuna. It should be accessible. People should be able to understand it quickly, depending on the audience, and it has to be elegant enough. Next takeaway I would say is, uh, if you're just using one toolkit and they're saying, if all you have is a hammer, everything looks like a nail, right? So I would say improve your toolkit of visualization, which allows you to look at the data very differently rather than being limited to what that tool can do, right? Because what you visualize is a response to the questions you have in mind, right? It's not a response to what the tool can do, right? And therefore, depending on whether you have question A or question B, you should be able to pick different tools to answer that question, and not say, oh, I just have a hammer, so only thing I can do is hammer and see everything like a nail. No, you should say, okay, this is the question in my mind. Maybe my tool doesn't allow me to answer that or visualize that. Let me pick something else, right? So you should have an arsenal of different kind of tools. That is very important. Right? Try to find hierarchy in the data. So look at all the different levels. Try to look at the levels at the same time, because that helps to understand the relation between the part and the whole. And the hierarchy can be, say, temporal hierarchy, or it can be the physical components of the buildings at the building level, system level, component level, and so on, right? And if you can do this hierarchy and superimpose, juxtapose on the same graph or side by side, it adds a lot of value, and it helps you to improve your proposal. And then layering, you can have a data, and we saw some example of this. You highlight some parts of the data, you annotate it, and then the whole thing becomes a story which is very compelling, which is very has a huge communication value, right? Connecting the dots, and I'm a big proponent of this. You have all these numerous ways of visualizing, but each of them is not a standalone end in itself. Each of them is a means, and then it comes to you to how do you uh, connect all these visualization to develop far more deeper insight to create much more holistic picture, right? And that is where I say that you start from data to information to knowledge and to wisdom, and improve your performance, right? So the last slide is slightly edited version of Eliot's poem. Is just flip it around, that by the end of it you should say, where's the information we have lost in the data, right? That is the question. Where's the knowledge we have lost in information, and where's the wisdom we have lost in knowledge, and where's the life we have lost in living? So with that, I will stop and open to questions.
Thank you, Saket. I hope our participants will be able to will have got a better insight into what kind of visualizations and how they can represent data. And I think I would like Prasad to. I think he wants to talk about a few things. So, Prasad.
Thanks, Yashima. Am I audible?
Yes.
Yeah. Saket, thank you so much. I mean, that was such a deep and wonderful talk on data and visualization. So, I guess one of the things that I wanted to throw out as a discussion point here, especially because these students and participants are in the last 3-4 weeks of their submissions, trying to pull stuff together, etc. And they're sitting in different places in different cities because of the pandemic. They aren't able to be with each other. They're working from home, And obviously there's going to be a lot of craziness, to put it in one word, about the way they're working right now and the way they're experiencing time to be able to do the work. And some of the stuff that you talked about really requires time, not because it's temporal data, but it just needs time to understand what's going on. It needs patience. It needs a person who's thinking about this to clear their minds and be open to the exploration. So, and you yourself have worked in so many different situations where you might be in a time crunch, etc. How do you then, you know, what's the strategy really to be able to say, okay, I have a limited amount of time, I need to do a fair amount of exploration, and I need to come out with something that is trustworthy, whatever those three principles were, elegant and accessible. So, it my question is, you've been in these situations, can you provide some insights as to how to strategize about going about this?
So thanks, Prasad, for asking that. I think that's a very, very important question. Uh, Visualization is kind of outcome, but the process of exploration and synthesis, it's a kind of a bottomless pit, right? You can get into it and keep doing it, and because it's exploration, it's like treasure hunt. You never know what you'll find, right? So if you are aimlessly wandering, it can consume your whole life. And given that you only have 3 weeks, it's very important that you'll have to be extremely strategic about how much time you spend on these things, right? So there are a couple of ways to look at it. First, as a team, you'll have to say, are there questions that are still unanswered? Right? Are there opportunities that you have an intuitive feel that are unexplored? Right? Or what stage are you in your design? If you think you have pretty much taken all the major decisions, right, then you need to focus your efforts to how to best communicate those decisions to the audience, to the jury, to the final presentation, uh, and how to best defend your the reasonings that you are kind of taking out, and support your decision, right? So then that is where you should focus your attention. But if you are feeling that no, I've improved my performance only this much, but I'm unable to break that ceiling to go from performance level A to B in terms of energy saving, right? And if that is the question you're struggling with, then you would have a different visualization and exploration strategy, right? There you would go down to raw data and start looking at things from there, right? If you're somewhere in between, then you would do more layered thing, that you would have more hierarchical thing, that components and uh, the synthesis thing side by side, to say, okay, I have kind of nailed down these 5 topics. I have done good on water. I've done good on thermal comfort. What is missing? And so it has to be driven from what stage you are in the competition. What is your kind of intuitive feel about the improvement possibility in the design? Maybe you've done everything, you have a lot of time to say, okay, I've reached the 90% potential. Now there's scope and time for the 5% potential. Then you get into the deeper analytics to say, where can I squeeze in that extra 5% of saving, right? But if you think you're just hit 30% of saving and you have a long way to go, then maybe there are other low hanging fruits and you don't really have to go into the deeper analysis yet. I hope that partly answers your
Yeah,
question.
yeah, I think so. It's about recognizing what stage you're at, how much time you have, and then either focusing on communicating the information that you have best, or delving into exploration, or sort of being somewhere in between, in a sense. Yeah. The other thing that I wanted to point out from one of the things that you showed on slide 45, if we can go back to that. This is not a question, but this is really to get the participants to really think about it in this way. We can share that slide.
Yeah, Saket, you'll have to share your screen again.
Okay, let me jump to that slide. Give me a minute. So it
Yeah.
says 45 on the slide number, right?
I think so. It was the one that showed the thermal comfort band and the HVAC system at the bottom.
Yes.
The temperatures.
Just a second. Yeah.
Yeah, thanks. So, so there's this, and there was another one where you had also shown sort of a heat map of the thermal comfort band with an HVAC operation on top of it, and yeah, it's okay. I mean, we can,
Yeah. Okay.
yeah.
All right. Yeah. It's somewhere. Yeah.
But the point that you made here, which I really want to stress on, is that this kind of a presentation of data, and Saket said this, and I'm repeating it, really allows the juries, the audience, to see what is the logic, which is what is represented on top in terms of how you interpreted the data, translating to your design strategy, which is shown at the bottom over here. And this is a very good way of approaching any kind of information that you want to present to the jury. It's not just about graphical information, it's also about writing stuff. You have to be say, this is my rationale, this is my data, this is what I've observed, and therefore I'm taking this decision, and this is how it's going to work. So these points of communication are very, very important in being able to convince the jury that you've done your homework, and that you're not just choosing a system and operating it, or you're choosing a strategy and just making a guess, but that you've done the homework to know that it is required in a certain way, and then it's going to operate in an appropriate way also. So I just wanted to make that as a stress on that. And so that, and I think a similar thing was there in that heat map that you had shown, where the points were identified where the points of thermal comfort were, and then it sort of showed where the air conditioning system was required as a result of that. So same thing happened over there as well. So after pointing that out, I think I'm going to turn it over now to you and Yashima in terms of taking the questions of the rest of the audience. Thank you.
Thanks, Prasad. So, Saket, we have a few questions and we'll take them one by one. So, the first question is, can overloading a graph with a lot of information become confusing for the reader? And how do we make sure to avoid this and provide just enough data to give a clear picture?
Right. Again, this is a very, very good question, very important question, right? And it all depends on your audience, right? And the purpose of your graph. So if I am the audience or my team is the audience, right? Then, and I have the luxury to sit with my team, maybe physically or virtually, to explain what is happening in the graph, then overloading is okay, because it's a tool to discuss, to engage, right? But if the graph is to communicate an outcome, right? But you also need to defend that outcome. Maybe if somebody asks a question, right? Then you can have a more layered approach where the overloaded thing kind of goes in the background, right? And the final thing is in the foreground. So for most people, they would not be too distracted with the background. So let me pick one example here. In the neighborhood only, if I'll pick that. Uh, okay, I don't remember where. Okay, so the extra information is the background in a manner that it is not disturbing, right? So that the focus on the foreground is still maintained. So this one, right? So this has a lot of information, right? This is almost as dense as this, right? But then again, this kind of visualization says that the extra information is in the background, and if you have a question, you can respond to that question. But for most practical purpose, the key thing that you want to highlight is in the foreground, and so the confusion is not there, right? So I think again it's a balance between why you're making that graph, who your audience is, and whether you are going to be there when that audience is going to look at the graph or not, right? And whether you want to use the graph to communicate something or to engage, right? So all of this would uh, decide the choice of the final complexity of the map you're making. Next, yeah.
Right. Yeah. Thanks, Saket. Next question. How do we effectively use 3D graphs?
Yes, so I am not a very big fan of 3D graph, right? Unless you are in something called a virtual reality environment, which is now becoming more common than what it was a couple of years ago, right? Because if your mode of communication is a 2D screen or a paper or a physical report, then you're projecting the 3D thing into a 2D version, and in that projection, a lot of things get lost, right? And therefore, there's a lot of chance of misinterpretation or information loss. Right? So there are ways, I've not included that, called dimension reduction ways, in which even if you have three dimensions of the data, you can still visualize it in 2 dimensions without any information loss, without any loss of credibility or chances of misinterpretation. But just 3D pie charts, 3D bar graphs, they are extremely misleading, because it all depends on what is the angle you have chosen. And you can choose an angle that tells your side of the story, but may hide consciously or unconsciously what actually is happening behind the scene. Right? So I would say avoid 3D graphs.
Right. Thanks, Saket. Next question. May we know the tool to develop all such graphic presentations, as only simulation and software outcomes are not sufficient to develop such level of visualizations / presentations?
Okay, so this is important. I have a good answer, right? But let me build on that answer. Uh, so as one of my takeaway slides said, if all that you have is a hammer, everything looks like a nail. And therefore, if all that you know is Excel, then you will end up making things that Excel can do and not answer the question that really needs to be answered, right? So you need to increase the breadth of your tool set. And there are many softwares that are now capable of doing a lot of things, right? So Yashima, in her thesis, you have used some amazing tools and come up with some very amazing graphs. I think that in today's age, it's not so much tool dependent now rather than question dependent. And the minute you have a question and a strong urge to answer that question, you can use a off the shelf tool, a lot of online utilities that you can use, a lot of libraries that you can download and as a plugin use in your tool. So even if you just know Excel, maybe you can find a library for Excel that can allow you to do some of these things. There are more advanced tools that can help you to create graphs and visualization and analysis that is not conventionally done, right? I am a big proponent of an open source tool called R, which can, all the things that we saw today can be done in R, but it has a huge learning curve. So it's not something that you can pick during like a 3-week period, but if professionally, in your professional lives, you're really interested in doing more advanced visualization and more customized visualization, then you can use something like R.
Right. And I would also like to add that Excel in itself is an extremely powerful tool. And so the graph that Prasad was talking about previously, with the HVAC, the thermal comfort band and, comfort hours, the entire thing has been made in Excel. And I think there's a lot of help available online, YouTube, etc. And even if you are able to use Excel in the best way, I think you can produce fantastic presentations.
And thanks, Yashima, for bringing that. And the good thing about Excel is that layering of information and annotation is very easy. If you're using more advanced tools, then they're good for visualization, good for analysis. But Excel allows you to layer and annotate things in a very easy manner. Right? So as a post-processing thing, you can use Excel or Photoshop or other things to annotate.
Yashima, I remember you and some of your colleagues used to use a tool for online tool called Plotly.
Yes, I was going to bring that up. So there's another tool called Plotly, and there's also another tool called Tableau. So it's spelled as Tableau. These are some online tools which allow you to present graphs, make graphs, but they have more variety in terms of what kind of graphs you can make. So it has more variety as compared to Excel. But again, I mean, if I have to make something, I would do it on Excel rather than use online tools, because Excel is extremely reliable. So yes.
One of the slides that I had on alternatives to pie chart, all of that were from Tableau.
Yeah. Yeah. Right. Moving to the next question. So the next question is, while summarizing a data in graph, there is a possibility of getting an averaged out data. If at the same time we want to point out the accurate data, would you suggest putting both in the chart, like putting a pointer, highlighter, or a number?
Let me pull a example from one of my slides.
Yeah.
So here, see the dark line is the average, right? And the accurate data is behind it. So that is, I'm not saying this is the only way, this is one way where you have the raw data, the actual data behind, right? And the average data in front of it. Or this one where again the average data, a super average, I would say, is the dark black line. And behind it is a box plot, which is one level of synthesized data. You don't see the raw data here. So for every hour, you get an kind of a distribution for the whole month, right? And then you get this black line, which is an average of all of that. So again, I think the layering of information can really kind of address some of the things that is being asked in this question.
Right. Another question we have is a software related question. So for flow or Sankey diagrams, are there any tools available that we can use?
Yeah, so there are a lot of, I think, online Sankey things nowadays. I know R can definitely do that. I think Excel has a plugin for Sankey nowadays. So
Yeah.
it's no more a fancy thing, but I think it's still very powerful for flows.
Yeah. Also, Google Charts is something that you can look at. So it has a lot of options, and it can be act as a plugin in Excel, I think. I'm not sure about that though. So Sankey diagrams are a possibility in Google Charts.
And just adding one more thing that Prasad said, because everybody is kind of virtually uh, working as a team, you can use a lot of online tools and share those kind of things between the teams. Right? So the D3S visualizations and high charts and things like that, which will let you do the Sankey and interactive things and layering of the information very well. And then you can easily share among your team member, even they're physically far away, who can actually play and interact with these data. So again, interactive data is something I've not talked about, but when you're in the exploratory mode, that is something that is a good tool to collaborate.
Right. And one last question for today is, many charts and graphs presented were not the ones that we conventionally have on Excel. Is post-processing done for those? And if so, then can you please advise us on how to achieve optimum accuracy?
So let me see if I get this right. Yes, many things are, the examples I've shared are not available in Excel, but you can, I think, make a lot of them in Excel. It's not with menu driven quick things, but if you can do a little bit data processing within Excel, which is not very difficult, many of these things can be produced within Excel, right? I have picked the example from multiple sources, but I think about 80-90% of this can be achieved within Excel, either through very easy processing in Excel or adding some libraries, right? Now, the question is about optimum accuracy while doing post processing, right? So, if by post processing you mean that take it to Photoshop and add some summary on top of that, then yes, there may be questions of accuracy. But if you're doing that layering within Excel and doing the post processing to add annotations or highlighting, then the chances of error are very less. Right? So you have the layered thing in Excel, and then you take it to Photoshop where you are makes fading things out or highlighting things or adding annotations. Then I think there's no loss of accuracy there.
Right. And I think just one thing I want to add is that when it comes to spatial representation, then I think, Excel is not very handy. And a few presentations that Saket had shown, which were done during my thesis, I had done it on, honeybee and ladybug. And the presentations were produced right. I mean, they were produced as is from honeybee and ladybug. So spatial representations becomes challenging in Excel. But of course, you can overlay building sections which are done in Photoshop with graphs which are done in Excel. So those kind of things, and that's where your innovation lies, how you present your data. And I mean, spatial data is something which becomes challenging for Excel, and you would need additional tools for that.
But
Yes.
I have seen there are a lot of data viewers nowadays which can directly take output from Energy Plus and then give you a lot of these things that we shared today. Like they can just spit these things out. Right?
Right. Yeah.
But I would always suggest that start with a question, start with a purpose, and then find which graph suits you rather than getting deluged by 1 million different types of graph just because it is you've seen it. So say
Yeah.
what is the question
Absolutely.
what is the question you want to answer, why you want to do it, and then find the right tool to do it.
Right. All right. So thank you so much, Saket. That's all from our questions for today. And Prasad, do you want to add anything else?
No, I think this was a brilliant session. I
Yeah.
really enjoyed what Saket talked about, and it was really nice to see the breadth of stuff one can do.
I had fun putting these things, and thanks Yashim and Prasad for helping me to put these things together. So really couldn't have been possible without your support.
Yeah, and just one last thing. So this webinar will not be uploaded on YouTube. It will be available on your learning platform. So if you want your teammates to have a look at it, please ask them to look on Moodle. It will be uploaded in 2 to 3 days. But this webinar will not be uploaded on YouTube. And lastly, I would also like to wish the very best to all our finalist teams. I know the final submission is just 3 weeks away, and we hope to see some fantastic work once again from all of you. And we want you to make our job even tougher. And wish you all the very best.
And I totally second Yashima. The teams are doing phenomenal work. I'm very impressed with the quality of submissions, and I wish all of them all the best.
Yeah.
All the best, everyone.
Okay. Thank you, everyone. Bye bye.